My name is Catherine Bovey, and I'm leader of the Ohio State EcoCAR 2 team. EcoCAR 2 is a 3-year competition sponsored by the U.S. Department of Energy and General Motors that challenges 15 teams of university students to redesign a production vehicle so it gets better fuel economy, better emissions, but still maintain the same performance and consumer acceptability as the original vehicle. And so to attain these goals, the Ohio State team has decided to make a parallel series plug-in hybrid electric vehicle over the next 3 years. And this vehicle will be able to operate in charge depleting mode, charge sustaining series mode, and charge sustaining parallel mode. And obviously this is a very complex vehicle that has different operating modes. And so we have to have a control system that's able to handle that and figure out what mode of operation the vehicle is in. And so our team's designing our own vehicle supervisory controller, our own engine controller, and our own transmission controller to meet these needs. And so to make sure that all 3 of these controllers can respond correctly to different operating conditions in the vehicle, we're using dSpace hardware and software to not only develop the algorithms for each of these controllers, but also test each of the controllers' code for different fault conditions the vehicle might see while it's operating.
The first controller our team is developing is the supervisory controller. This is based on the dSpace Micro Autobox 2 platform. This controller is in charge of what mode you're in, whether it's charge depleting or charge sustaining, as well as it's in charge of the torque split between the electric motors and the engine, and also determines what gear the transmission is in. The dSpace hardware in the loop simulator allows us to test the controller and its communication with all the other controllers in the vehicle, as well as its fault detection and mitigation. Another controller our team is developing is the transmission controller. This is based off the Woodward 128-pin platform. This controller drives the actuators required to shift gears when the supervisory controller commands a gear change. The dSpace hardware in the loop simulator allows us to test the controller and calibrate it so that when we transfer the transmission into the vehicle, we get good, reliable gear shifts. So the third controller that our team is developing is the engine controller. In the previous competition, our team has recalibrated a high compression ratio compressed natural gas engine to run on E85. Currently, we are in the process of migrating the engine control code from a previous controller to the ETOS Flex ECU. The dSpace hardware in the loop simulator allows us to test that control code before that we implement it on the dyno to make sure that it's functioning properly and won't cause any problems when we do put it on the dyno.
Our team has been using DFMEA and FTA techniques to identify the failure modes of the vehicle and subsystems, as well as the best way to mitigate them. We use the dSpace hardware in the loop simulator with dSpace Automation Desk to simulate the faults and test our controller's response. Through testing with the dSpace hardware in the loop simulator, our controllers will be ready to implement in the vehicle during year 2.